Now we are going to see the inverse Z transform. So the inverse Z transform means it's a process by which the x of Z is returned to the time domain. So that is the inverse Z transform. So in Z transform, the sequence x of n is changed to x of Z. Now for inverse Z transform, the x of Z changes to x of n or x of k. So that is the inverse Z transform. So x of k equal to Z power minus 1 into x of Z. So here we have the methods to calculate inverse Z transform: inspection method, partial fraction expansion, and power series expansion method. So now first we are going to discuss about inspection method. So in this inspection method is based on the Z transform pair table. So we have the Z transform pair table. From this Z transform pair table we are calculating, because in the Z transform pair table we have this standard Z transform. For that is Z transform, the standard sequences are there. Okay, so in Z transform pair table they have defined the sequence and the corresponding Z transform. So for taking the inverse Z transform, we have to compare x of Z with the standard Z transform pair. Like this we have to calculate the inverse Z transform. But in some time the x of Z is not in the Z transform table pair. So at that time we have to use partial fraction method to simplify the given function into the standard one. After that we can get the inverse Z transform for the standard Z transform. So here these are the sequence so these are the standard sequence. For this we have the Z transform. So del of n is the impulse signal. For this Z transform value will be 1. And here u of n is the step input for this Z transform, Z by Z minus 1. So like this we have these are the standard sequence and its Z transform. So we have to convert the sequence into the standard one. After that we can calculate the inverse Z transform. So that is the one method, that is inspection method. So next one we are going to see the partial fraction method. So in partial fraction method we are going to calculate the inverse Z transform for rational functions. That means the transfer functions having the numerator of order m and the denominator have the order n. So partial fraction method, we are applying partial fraction method for the rational functions. So the numerator having some order and the denominator having some order. Now at the situation at this time we are using partial fraction method. So next one, the partial fraction method can be used only if the numerator order m is less than the denominator order. Then only we can apply partial fraction to calculate the inverse Z transform. So for applying partial fraction method to calculate inverse Z transform, we have the numerator and the denominator. So the numerator of order m and the denominator of order n. So the order of the numerator should be less than the denominator order. Then only we can apply partial fraction method. Next, if the numerator order is greater than or equal to the denominator order, means we have to use long division method to make the denominator order greater than the numerator order. So for partial fraction method, we are using this method to this transfer function having numerator order is less than the denominator order. Then only we can apply partial fraction. If the numerator order is greater value means with the help of long division method we have to convert this into the denominator order n greater than the numerator order. Next we have to apply partial fraction method. So the long division converts the x of a z function in the following form. X of z equal to sigma r equal to 0 to m minus n. B or z power minus r plus sigma k equal to 1 to n ak divided by 1 minus dk into z power minus 1. So here we know that m is the numerator order and n is the denominator order. Ak are the constants of the partial fraction, dk are the roots. Here find the inverse is a transform for the sequence given by x of z equal to 1 plus 2 z power minus 1 plus z power minus 2 divided by 1 minus 3 by 2 z power minus 1 plus 1 by 2 z power minus 2 for this sequence. So this sequence having the denominator and the numerator having the same order. So in this situation also we have to use long division method to convert the denominator order is greater than the numerator order. So here this is the long division method. So we are writing the numerator here and the denominator here. Again, so first step we have to make the first element as 0. Our aim is to make the first element. When we are subtracting this element, we have to make 0. So for this I am multiplying 2. We are writing 2 here. Then only when you are multiplying 2 with this number, we will get z power minus 2. So ultimately this term will cancel. So we are writing 2 here. Then only we can get z power minus 2 in this place. So multiplying 2 with 1 by 2 into z power minus 2 means the answer will be z power minus 2. Next 2 into 3 by 2 into z power minus 1 means we will get minus 3 into z power minus 1. Again 2 into 1 plus 2. So finally we will subtract z power minus 2 here minus z power minus 2 means this term cancel. Next here this value. So in the this function we are changing the sign. For doing the subtraction we are changing the sign. So here it will become minus and this term become plus. So we are doing the subtraction means here it will become minus and it will become plus and here also it will become minus. So we will cancel this term and we will get 5 into z power minus 1 and minus 1. So this is the procedure for the long division method. So we will write x of z equal to 2 plus minus 1 plus 5 z power minus 1 divided by 1 minus 1 by 2 into z power minus 1, 1 minus z power minus 1. So this term we can write like this. 1 minus 1 by 2 z power minus 1 into 1 minus z power minus 1. So x of z equal to, or this is the standard form, b non plus a1 divided by 1 minus 1 by 2 z power minus 1 plus a2 divided by 1 by 2 z 1 minus z power minus 1. So we are applying partial fraction. So here b non is the constant 2. So now we are applying partial fraction here. So next we have to calculate a1 and a2 value. How will you calculate a1 value? So for the calculation of a1 value, you have to write x of z. X of z. So this is the x of z function. So write x of z into the denominator of a1. So this is the denominator of a1. So you have to multiply x of z with denominator at the time z value equal to 1 by 2. So this is the root of the denominator of a1, z equal to 1 by 2. So when you are solving this equation, you will get minus 9. Next we are going to calculate a2. So for the calculation of a2 also we have to write x of z. So this is the procedure for calculating a1 and a2. So x of z into the denominator of a2 term at z equal to 1. So z equal to 1 is the root of a2. So its value will be 8. So next we can write x of z equal to 2 minus 9 by 1 minus 1 by 2 z power minus 1 plus 8 divided by 1 minus z power minus 1. Next we have to, as compared to z transform per table, we can write 1 by 2. 2 means the z transform. So for the value of 2, the inverse z transform will be 2 into del of n. Like this, 1 divided by 1 minus 1 by 2 z power minus 1. So its inverse z transform will be 1 by 2 the whole power n into u of n. So for this z transform, its inverse z transform will be u of n. So these are the standard z transforms available in a z transform per table. Therefore the x of n, the sequence is given by x of n equal to 2 into del of n minus 9 into, 9 is the constant, 1 by 2 of the whole power n into u of n plus 8 into u of n. Next one, power series expansion method. So in power series expansion method, from the definition of the z transform, we can write the z transform as x of z equal to sigma n equal to minus infinity to infinite x of n into z power minus n. Now we are expanding this function, so we will get the Lorentz series. Now in solving the calculating the inverse z transform for the sequence, so we have to expand that sequence, and comparing these values with that sequence, we will get the inverse z transform of that sequence. Okay, thank you.